Okay, let's begin our review session. So first, thank you for all three of you to come to my review session. And okay, so the topic included today. Today I'm gonna talk about chapter 1.3. So, but after that, if you have any questions about chapter 1.1, 1.2, or any other questions, you can just ask me. So right now is I'm gonna introduce the mathematical models. So the professor talk about the previous classes. So the first one is the population growth and the radioactive decay. So you can compare these two models. They are so they exactly the same, but for the population growth, the k here is a positive number, but the k at the decay is a negative number. So and the I don't know whether it works. Okay, it works. So if we see the plot of the population growth, it will uh, yeah, it will look like this. Oh my god, I just forgot about that. So okay, let me do it. So it's E over equals KBT. So yeah, and when you take each of those, it should be an exponential increase exponential function, and for this one, it's just the k. So the only difference from these two models is the k here. Okay, so and for the cooling and warming process, we have the model like this, and the T here is the you can say it's the temperature of the environment. Let's say if we okay the potato for example, if you grab the potato from the oven to the room at here, so T here is just the room temperature. So the room temperature is always constant. So I mean, you will learn how to solve it maybe in the future. So I'm just give a brief introduction to this, and so these are the three, maybe two simple list models. Do you have any questions? Okay, so let's jump to this one. So okay, so here's the tank problems. So for the tank problems, this problem is just the exact one from the website. So let's say it's suppose that we have a large tank here, and it contains 50 pounds of water. It's 100 gallons of water. So 100 gallons of water with 50 pounds of salt in it. So okay, let's stop at the first sentence here. So from the first sentence, so what do we know from the first sentence? So how many information can we know? So we know that it has the original volume of the tank is 100 gallons, and we have 50 pounds of salt. So if A is amount of salt in the tank, the initial volume is so A0 is 50 because if no water fill in and no water come out, so when T equals 0, there will be exactly 50 pounds of salt in it, right? So when T equals 0, there is A0 should be equal to 50. So that should be an REP problem, right? Okay, let's see the second sentence. So another brine solution is poured into the tank at a rate of 3 gallons per minute. So we have water poured into the tank right now at a rate of 3 gallons per minute. Because it's a brine solution, so this amount of water coming into the tank contains no salt, right? So okay, let's stop at here. If the water come in, the amount of salt in the tank remain the same, right? And let's move on. So it is then poured out at the 2 gallons per minute. Okay, so let's see. The water coming in contains no salt. but the water goes out will contain certain amount of salt because we have 50 pounds of salt in the tank initially, right? So and the concentration of the solution. Okay, I'm sorry. So there. So the concentration of the solution entering is 3 pounds per gallon. Okay, so I'm really sorry. It do contain salt. So that is 3 pounds per gallon of salt coming in and 2 gallons per minute of the solution coming out of the tank. And we're going to find the EADT. So A is the total amount of salt in the tank, and we're going to find the ADT, that is the rate of salt leaving or entering the tank, right? So you need to remember this formula. So dA over dt. How to find dA over dt? You need to find the rate of salt coming into the tank and the rate of salt going out of the tank, and you use R in, subtract R out to find out what is dA dt. Okay, so once we have that formula, we need to find out those two rates. So the rate of salt coming in is, we know from here, there are 3 gallons of water per minute water coming in, which contains 3 pounds per gallon of salt. So the salt coming in is 3 times 3, right? That makes sense? And now we are going to find the rate of salt leaving the tank. So the solution leaving the tank is 2 gallons per minute. So 2 here, but what is the concentration of salt in the tank at a certain time? Okay, so we know that we defined the amount of salt in the tank is A, right? So there are totally A of amount of A salt in the tank, and so the concentration is amount of salt over the volume of the volume of solution in the tank. So we originally had 100 solution in, but we know that the water coming in is greater than the water leaving the tank. So how much is 3 minus 2? So, and the water will accumulate in the tank. So we use 100 plus 3 minus 2, which is 1 times T. So that is the volume of water related to time in the tank, right? Is that making sense? I know
Yeah, that makes total sense.
Okay, thank you.
So it's the gallon, like the amount for the bottom part, it's the total.
Yeah, the total volume
plus
in the tank.
The in minus the out.
Yeah.
Which is
just
T.
means 1.
Yeah.
So this is so the concentration is the amount of salt in the tank over the volume of solution in the tank. So the original volume is 100, but we have 3 gallons per minute solution come in, and we only have 2 gallons per minute leaving out. So there will be 1 gallons per minute left in the tank. So we use 100 plus 3 minus 1 times T.
Or 3
That
minus
is
2.
So then you can get the function, which is like this. So that is what we want for the ADT.
You meant 3 minus 2 there.
Oh,
A over.
Here?
No.
This.
On the bottom of that,
Yeah, this is the concentration.
Yeah, but A over 100 plus 3 minus 2.
Sorry.
Yeah. To get 1.
Yeah. So you have questions so far. So this is the tank problems with the water coming in is greater than the water leaving the tank. So you have any questions now? Okay, so let's change these problems.
Okay.
So if there a safe rate of water leaving. So at this function, where I should change?
The concentration.
Yeah, the concentration. So where?
3 minus 3 now, so the T just disappears.
Yep. So this part, because the amount of water coming in is equal to the water leaving, so there will be always 100 gallons of solution remain in the tank. So you simply get rid of this T here. And the last one is if I change this to 2. So there now we only have 2 gallons per minute of solution coming in, and we have 3 gallons per minute leaving. So what should I do right now?
It'll be minus T now because the volume is decreasing
Yeah.
by 1 gallon per minute.
So I hear you just put 100 minus the subtraction, so 3 minus 2T, or because the water will eventually all leaving the tank, right? So that's 3 types of the tank problems, and there'll be no more, just these 3.
Okay.
So remember this, and I think I will talk about this again maybe several weeks later. So you have any questions so far? No? Okay. Okay, so let's move to the circuit problem. You like it?
Yeah, it reminds me all about circuits.
Okay, so there are 3 types of circuit problems. So the easiest 2 are RL circuit and RC circuit, and RLC circuit is a little bit complicated. It just makes the resistor, capacitor, and the inductor, but they should all the same if you know the equations. So okay. The first. So here is the RL circuit because it only contains inductor and resistor. So the equations you should know is that. So E is the total voltage of the circuit, and the total voltage over circuit is the voltage across the inductor plus the voltage across the resistor, right? So let's separate this. So what is the voltage across the inductor if this is I? So it should be L, the inductance, times dI over dt, right? And for the voltage across the resistor, it simply follows Ohm's law, which is R times I, very small. Okay, so what about the voltage across the capacitor? You can write in several different ways. So one is 1 over C, the integral of I dt. And we know that the capacitor is to store charge, right? So, and we know the amount of charge is equal to so I is equal to dq over dt. So just keep this in mind. Okay, so for the RL circuit, so the total voltage is E, and the voltage across the inductor is L dI over dt plus the voltage across the resistor, which is R times I. So that is basically what you need. And if the question asks you what is di dt in the RL circuit, and you just like put it over, and that is 1 over L E minus R times I, right? So that's for the RL circuit, and for the RC circuit, it's just the same, and you need to write down the equations. So the total voltage is E, and the voltage across the resistor is R times I, and the voltage across the capacitor. So related to your book, you'll just replace I with Q. So okay, so that is 1 over C times Q here. So this part is just the same as this part, right? Because I is equal to dq dt, and if you take integral of it, so the integral of I is this part, right? And it's just the q, so this part is equal to q. So the voltage across the capacitor is 1 over C times Q. So, and if we replace I here with Q, that is R times dq dt plus 1 over C Q. And usually the question will ask you, what is dq over dt in the RC circuit? And the same thing, you put, sorry, it's a little bit mess. dq dt is equals to E minus 1 over C times Q, and U times 1 over R here. So that is, so here you got dq over dt, and here you got di over dt. And so any questions so far for the RL circuit and RC circuit? So probably you are familiar with the so maybe familiar with this one, and not very familiar with this one, right? Or
I'm not familiar with either.
okay. It's okay. I mean, you
I'll
will
learn.
learn that, but
I'll
I'm
learn
just
this semester.
probably give you an introduction to that.
Yeah.
You have no questions so far. So let's go to the RLC circuit. So actually, the RLC circuit is a combination of those two. So this is a capacitor, this is an inductor, and this is a resistor. Okay, also I want to mention that for the RL circuit and RC circuit, it's a first order differential equation, because for the equation I just wrote, it only contains di dt or dq dt, right? But for the RLC circuit, we will move to the second order differential equation. Okay, so let's do this. So the total voltage is equal to the voltage across the inductor, which is L times di over dt, and plus the voltage across the resistor, which is R times I, and the voltage across the capacitor, which is 1 over C times Q. Also, we know that I is equal to dq over dt. So we can replace this part and this part with q. So we got the whole function only contains q and t. So how to do this? So okay, so we know that I equals dq over dt. So if we keep taking integral of derivative of I, so di dt is equal to, we take another, is dq squared over dt squared, because we take another derivative of that, right? So, and we got this, so L times di dt, which is, which is this over dt squared. And for this one, we keep the r here, and we replace I into dq over dt, and we keep the q here. So here we got our final equations. So a function only contains q and t. So, and we can see that here you have the two here. So that is the second order differential equation. So it's a little bit complicated, but it's all the same once you know the voltage across the inductor, resistor, or the capacitor. So, have any questions, or should I explain more? Or just say it is okay.
Like, what would you be doing with that?
This one?
Like, if it's on the homework, like what?
So it looked
I
like
think
a
these
one
two
question.
are on the homework, right? The RL circuit and the RC circuit is on the homework, and I think the homework is asking you, so what is the so what is the di dt, or what is dq dt for these two? Yeah, so hope you can remember how to solve di dt or dq dt. So I mean, for this kind of problems, you need to know the relationship between, like, if it wants you to find out what is di dt, then you need to relate. I don't know how to say. You need to find the, find the relationship which is related to I. Like let's say for this one, we use I, but for this one we can also use Y to describe the voltage across the capacitor, right? But the question is asking you what is the relationship, what is the function of dq dt? So we need to replace I with q, because there are also a relationship between I and q, since I is equal to dq dt, right? So you will be familiar with that. Maybe after some practice, but I just give a brief introduction to that. Hope it's not too much for you. Sorry. And
So much better.
okay, so here's the last one. Okay, so this is also the homework problems from your from website, and I think professor talked a little bit about these problems, and it's on your note, I think, but he just directly give you the equation of the dh over dt, but right now I want to give a deep explanation on how he got that equations. So. So can you clear see this? Okay, so there is a cube, and then there's a circular hole on the bottom of the cube, and so water can leak through this hole, and the rate of water leaking. That's great. I don't know So the water leaving the tank through this circular hole is at the rate of, okay, so it's at the rate of C times AH square root of 2GH. So here C is just a constant, and the AH is the area of the hole. So here, that's the area of the hole is AH. And is that, so, and we want to know what is dH over dt. So first, we need to, oh, I already came this one. First, we know that H is equal to the volume over area, right? And so based on this, we need to find out what is the volume and what is the area. So this is the H, and we know that, but let me think how to say that. Yeah, so actually what I did is first, based on this function, so the only volume right now I know is the volume, the water leaving the tank, right? Because you have the rate, and so the volume, so this is the volume leave the tank, is the rate, which is C times AH times 2GH. So this one is given, so you don't need to care about this, times T. So this is the rate of solution leaving the tank times T, so that is the volume of solution leaving the tank at time T. And so we can know that delta H, which is here, that is the decrement of the height because caused by the leaking of solution. So this one is the volume of water leaving over the area. So at here the area should be the area of the tank. So here the area is AW. But the question is asking you what is the dH over dt, and the h here is the h from here, so it's not the delta h, it's this h. So but we know that this h is equal to the total height of the tank, subtract the delta h. So at first I write all these things down so it can help me to know what should I do next. So based on these three equations, and I put all the information in it. So at here I'm going to find what is the, so right now I know the volume of water leaving, so I put C, which is this equation, GH times T, and over the area of the tank, which is AW. And here, so it's like a step by step. So 10 minus delta H, which is this equation, times T over AW. Okay. So right now we have the equations of H and T, but the question is asking you what is dH over dt. So you just take the derivative of H. So that is, you take derivative of H, and on the left you get dH over dt, and on the left, so what is the on the right if you take derivative of this whole things? We're going to take the derivative of t. So What
10
about
disappears.
Yep, so that is 0, right? And what about this part? We only have Tx here.
Yeah, it's just
So,
constant times
yep.
t, so
So that should be the constant. So it should stay here and AH 2GH over AW. So this one is a answer you need to put on website. But there are some tricks on website, so but I'm not gonna tell you. But basically, it's the formula is correct, and you need to pay attention to the unit. So
What was C?
what?
yeah, is c just a
Oh,
constant?
C,
or-
yeah, C is a yeah, C is a constant, and you don't need to care about C. You just leave C there.
No, at the beginning.
Where?
Like at the volume leaving.
Here?
Yeah.
Yeah, it's the same here.
Oh, it's the
so
same.
that is so this whole part is the rate of the solution living through this hole. So that is I think gallons per minute or something. But so you don't need to care about what is the
c probably changes depending on what's inside the
Yeah.
box. It's probably like
And then-
viscosity or something.
AH was like the area
yeah
of the
yeah
hole.
the AH is the area of the circular hole on the bottom. So
Makes sense.
any questions for this one? So I think the equations the professor gave in the class is, I don't know, it's dh over dt simply equals, that is equals negative an. I think probably an is the area of the circular hole over dt. Oh wait, no, it's not dt, sorry. It's the an over aw times 2gh. And so, yeah, probably because, and we can compare this two answers. We have 2gh here, and we have ah over aw, but we simply have the constant c here, but it doesn't matter. So, and you don't need to remember this equation, and it's not required. You just know how to solve it, and based on h equals v over a.
Okay, so like if we were having a test or something, would the volume leaving be given to us or something like that?
You mean the rate?
Yeah, like the
Right end.
This
which
is what, right? Yeah, it will
yeah
be.
something like that.
Yeah, definitely will give to you.
Okay.
And yeah, so probably that's it. So you have any questions about this one and the step things? No. Okay.
No,
So I think probably that's all for chapter 1.3. So do you have any question about chapter 1.3? I think there are maybe a lot of problems on the book because there are so many different models. I mean, those I can say that the tank problem, the circular problems, and the population growth and the radio activity or something decay and the temperature. Those are the 5 basic models you need to know. But for the last one, this one, I mean, you don't need to know that one, but because you can figure that out by yourself. So, but I can say, I mean, I'll say that the previous 5, they are important. So, but so right now it's not that important, but in the future they will be important. So, yeah, that's all I want to say. So if you have any questions about the lecture, about the homework or website, just ask me.
Yeah, doing the homework would be good.
So, I think
mean-
it's a little bit ahead, right? I don't know.
Oh no, it's great.
Really?
Because if I didn't come to here or anything, then on the homework I would have been like, how do I do this? But now I have all these notes how to solve like on one page, and I'm like, oh, I can do this.
Yeah, and once you doing the homework, if you still have questions, you can just email me and try my best to help.
Yes.
Yeah.
So
So
there's a review tomorrow.
I think it's on Wednesday. There will be a quiz and it contains I think chapter 1.2 and 1.3.
Okay, and it'll just be about this stuff. What was 1.2 on?
I think it's
Initial value problems.
yeah. Okay, so for that one, I'm not 100% sure, but I think for the initial value problem, probably he will give you a equation, but it contains the constant like C1 or C2 things, and he will give you like if it's the first order, he will give you one initial condition, and you need to figure out what is C. And if it's a second order equation, they are required two initial conditions, right? And he will give you two, and you need to solve C1 and C2, and just put it back to the equation, and you'll be fine.
Because if it's like a second order, you need like
so
you need two constants.
dy.
Yeah.
dx.
So usually, if there is a first order, like I don't know whether this is correct or not. So if this is a first order differential equations, it requires only one initial condition is enough. Because if you solve it,
C e to the negative x.
Yeah. So. But that it should be. I think here should be minus, right?
Then it would just be
it
C.
C to the e to the what?
Well, if you put minus, then now it's just e to the x.
E to the x. Okay, so if it's a first order and you only have one unknown constant here, but if you have second order things like this. I don't know, just put it like this. This one E. So it's 2 minus y equals 0, and you will get something like this. And y. You will learn how to solve it, but just take it as an example. So you have two constants here, so C1 and C2. So in order to figure out what is C1 and C2, you need at least two initial conditions, right? So that's why I'm saying for the first order you need one, and for the second order you need two, and the same for the third order equation you need three, and whatever. So the nth order, and you need to at least n initial conditions.
So we're given like y.
I think usually you will have equations like this, and I say, oh, this is IVP, and I'm giving you like y0 equals 1, and I'm giving you another initial condition, which is this equals 2 or something, and tell me what is the specific solution for that one, because for this one, depend on C1 and C2, you have thousands or, infinity equation for this one, right? Because C1 and C2 can vary. But if given the two initial conditions, and you can find the C1 and C2 to the values, and you put it back, so you got only one solution for that. Makes sense. Okay. So that's the initial condition problems. And we still have 20 minutes, and you can do works, or you can ask me questions, and
No, you did good.
Thank you. It's much better than the first time the last lesson.
Oh.
Yeah.
No, that all makes sense.
So you don't have any questions? No? And thank you again for coming, I really appreciate that.
This was so helpful.
I need to do this one.
You haven't done 1.2 already.